everyone, and welcome to Network Playroom. In this video, we're going to look at the OSPF Type 7 LSA or the NSSA External LSA in detail. So the NSSA is a new term and refers to a special OSPF area type called not-so-stubby area. Yes, they really named it that way. We haven't discussed the OSPF area types yet, but keep this term in mind for later use. So the NSSA External LSA is practically identical to the AS External LSA or Type 5 LSA, which I demonstrated in my previous video. And similarly to the AS External LSA, NSSA External LSAs are originated by ASBRs, but within an NSSA or not-so-stubby area. So all fields of the NSSA External LSA are identical to an AS External LSA fields, and carry the same information as the AS External LSA, with the exception of the type field and the forwarding address field, which I will get to in a moment. So of course, this field is going to indicate a type 7 for NSSA External LSA. There we go. And then here is the forwarding address that we'll look at momentarily. So first, before I get to any of that, let's go over the important fields again. So the link state ID field specifies the IP network number. So this field would include the external network that is advertised in this LSA. And then the network mask is the subnet mask for the advertised destination. So right here. So you could have in this field something like 192.168.20, 20.0, and then in here like 255.255.255.0. And then there's this EBIT or external metric bit, which specifies the type of external metric to be used with this route. However, I'm going to put an X on that E and change it to an N to indicate the metric type more accurately. So let's call that an N. So if you remember from the Type 5 LSA, this field indicated if this is an E1 or E2 metric. But with the Type 7 LSA, this is going to change a little bit, and it'll be either N1 or N2. So the reason I'm changing it is that if you were to look at the routing table, you'd see either N1 or N2 type code next to the route. And if the N bit is set to 0, the metric type is N1, and if the N bit is set to 1, the metric type is N2. So let me write that down here. So if N equals 0, then the metric type is N1, and if N equals 1, then the metric type is N2. And then the external route tag is a random tag that may be applied to the external route and is mainly used for external route management. So this field here. And then of course the metric field looks a bit cluttered here again now. Contains the metric for this destination right here. Alright, and again, let's skip the TOS fields because Cisco supports only TOS equal to 0, so we don't need to worry about those fields. So this one here, never mind that. Okay, so I just described the external metric bit, which I named the N bit to reflect the N1 and N2 metric types. So let's quickly go over the different bits in the OSPF packets types. And bear with me here because it's about to get rather confusing. So let me open up this drawing from one of my old videos. So this is the options field, which is present in OSPF hello packets, database descriptor packets, and link state advertisements. So here the E bit is meaningful only in OSPF hello and database descriptor packets, and when the E bit is clear in the hello packet sent out a particular interface, it means that the router will neither send or receive Type 5 AS External LSAs on that interface. In other words, the interface connects to a stub area or NSSA. And two routers will not become neighbors unless they agree on the state of the E bit. Now here, the N/P bit. The N bit is used only in hello packets, and the N bit is set when the originating router supports Type 7 NSSA External LSAs, and when the N bit is set in the hello packet that is sent out a particular interface, it means that the router will send and receive Type 7 LSAs on that interface. And neighboring routers with mismatched N bit values will not form a neighbor relationship. And this restriction ensures that all OSPF routers within an area support NSSA capabilities. And when the N bit is set to 1, the E bit must be 0. So let's write that down here as well. So when the N bit is set to 1, then the E bit, the E equals 0. And now I'm referring to this field. This is why I mentioned that it can get confusing, because now I've just named this other bit right here, the N bit, and this is a different thing. And then there's the P bit, which is used only in the Type 7 LSA header, and it flags the NSSA border router to translate Type 7 LSAs into Type 5 LSAs. And because the P bit is used only in Type 7 NSSA External LSA headers, the N and P bits can share the same position in the options field. This is why you see them here, N/P bit. Okay, and then secondly, there are the VEB bits in the router LSA. I don't have a diagram to show you here, but I'll show you later from a packet capture. So the V or virtual bit is set when the router is an endpoint of one or more fully adjacent virtual links. The E or external bit is set when the router is an AS boundary router, and all NSSA border routers set the E bit in those router LSAs originated into directly attached Type 5 capable areas. And NSSA's AS boundary routers also set the E bit in their router LSAs originated into the NSSA. And the B or border bit is set when the router is an area border router. So you can see that there are a lot of bits in different OSPF packet types, and depending on which bit you're looking at, it can have the same name, but it can have a totally different meaning. So you really need to be careful with this. I know it's confusing, but try to look at the packet captures and understand the differences. Okay, but moving on. So one thing to note about the Type 7 LSA flooding scope is that unlike AS External LSAs, which are flooded throughout an OSPF autonomous system, the NSSA External LSAs are flooded only within the not-so-stubby area in which they were originated. Now, this is where the forwarding address and the P bit come in. So the Type 7 LSAs have the propagate bit that, when set, tells the NSSA border router to translate a Type 7 LSA into a Type 5 LSA. And as I've just mentioned, the Type 7 LSAs are flooded only inside the not-so-stubby area, which is in which they were originated. And if these external routes are to be advertised throughout the OSPF domain, they must be translated into Type 5 LSAs. And this is indicated with the B bit. So let me write that down here as well. So if P equals 1, translate Type 7 LSA to Type 5 LSA. There we go. And those Type 7 LSAs that are to be translated into Type 5 LSAs must have their forwarding address set to a non-zero address. If the P bit is set, the forwarding address must be a non-zero. Otherwise, it may be 0.0.0.0, which means that the traffic will be forwarded to the NSSA AS boundary router who originated the LSA. So let's write down the other condition. So if P equals 1, the forwarding address must be non-zero. This field. And there are certain conditions that are required for the forwarding address field to be non-zero. And we will look at that shortly in this Cisco document. But first I want to show you the packet capture and go over the concepts that we've just looked at. So let me jump to this. So this is a new packet capture that describes the OSPF Type 7 LSA. So I have a link state update packet open here. So let's expand these fields and we can find a Type 7 LSA right here. So here you can see that it's a Type 7 LSA. Link state ID is 172.16.3.0. So that's the network number. Advertising router is 2.2.2.2. And here's the network mask, so it's a /24. And here's the external metric type, which I named the N bit. So this one is set to 1, so you can see that the type is 2. And here is the metric of the route. And now you can find the forwarding address. So notice here are the bits. So you can see the P bit is set. So this Type 7 LSA would be translated to a Type 5 LSA. And as you can see, the forwarding address was a non-zero value, as was required. And let's look at another one. Again, type 7 LSA. Here's the network number, the advertising router, the network mask, again a /24, also, external metric type 2 or N2. Here's the metric and the forwarding address. Nothing different here. But now let me just briefly go to the router LSA and I'll show you these options fields again. So here you can see the N bit is set. And again, this is a different N bit than what I had named previously in the type 7 LSA. And notice here, if you remember, if the N bit is set to 1, the E bit must be 0, which is right here. And just to show you a comparison, so let's open this type 7 LSA again. And then if we go back to this other packet capture and find the type 5 LSA, you can see that they are basically identical. So look at these fields. So we had the link state, ID, advertising router, network mask, external metric type, the metric, forwarding address, and so on. And now if we jump to the type 7 LSA, we can find the same fields. There we go, the LS type, link state ID, advertising router, network mask, external metric type, metric, forwarding address, and so on. Okay, but then let's briefly go over the conditions that must be set for the forwarding address field to be a non-zero address. So there's this document, I believe it's this one, called Common Routing Problem with OSPF Forwarding Address. So we'll ignore the rest of it, but let's focus on this part. Oops, I didn't mean to do that. I wanted to highlight the line here so you can see where I'm pointing. So these conditions set the forwarding address field to a non-zero address. So look at this list. OSPF is enabled on the ASBR's next hop interface, and ASBR's next hop interface is non-passive under OSPF, and ASBR's next hop interface is not point-to-point, and ASBR's next hop interface is not point-to-multipoint, and ASBR's next hop interface address falls under the network range specified in the router OSPF command. Any other conditions besides these set the forwarding address to 0.0.0.0. Okay, so all of this might not make sense at this point because we have not discussed OSPF area types or OSPF network types. So I will have to come back to these concepts in a separate video, but I just wanted to show this to you briefly. And in case you wanted to study this on your own, this is a nice document. And then let's briefly look at how the forwarding address is selected, because there are also specific rules for that, and these are demonstrated in this other great Cisco document, understand selection of forwarding address in OSPF. So we have this topology, and this external network 192.168.20.0/24 is advertised to the area 1, which is a not-so-stubby area. So R3 is advertising this route. So if we look at this LSA in the OSPF database, by the way, the command show IP OSPF database NSSA External is used to display NSSA External LSAs. So focus on these fields here. The forwarding address is 10.143.31.234 in both of these LSAs, or on both routers. So this was on R1 and here's on R2. So this forwarding address belongs to the interface between R3 and R1. So if you see the link here, I don't know if I can highlight this. No, I cannot. Oops, that opened it in another window. So yeah, why is that address selected as the forwarding address? Well, if you look at this part here. Oh wow. Come on, work with me here. Okay, now I've lost it. Here it is. Okay. So this part here, forwarding address, is selected on ASBR using the following rules. Number 1. If there is a loopback configured in the area, then IP address of loopback is selected as forwarding address. Number 2, if first condition is not met, then IP address of the first interface on the OSPF interface list is selected as the forwarding address. You can see OSPF interface list by using show IP OSPF interface, interface brief command. And the interface on top will be the last interface which was attached to OSPF. So basically, if a loopback is not configured, OSPF will choose the first quote-unquote OSPF address as the forwarding address. And this can be viewed with the show IP OSPF interface brief command. So here you can see that the address 10.143.31.234 is listed first on this list. But check what happens here when default configuration is applied to the Ethernet 0/0 interface, and then an IP address is configured on it and OSPF is enabled again. So now it is the last interface which was attached to OSPF, and it's going to be showing first on this list. So what has happened now, the forward address has changed to 10.143.31.230. So we have changed from the IP address from R1, on R1's end, on the link between R1 and R3, to R3's IP address on the link between R2 and R3. Now, of course, this is not very reliable, and it can be unpredictable and would result in network conversions. So it is advisable to have a loopback IP address as forwarding address, which is done here. So interface loopback 0 is configured on R3 with the address 192.168.3.3. And as you can see here, it is now the new forwarding address. Right, and then, okay, one other thing to note, that as with Type 5 LSAs, a separate Type 7 LSA is originated for each destination network. So let me jump to this diagram again. So here, it might seem a little confusing here, that as if we're advertising like several different type 7 LSAs or several different networks in the same type 7 LSA. But this is not true. And let me show you from RFC 3101 that this is actually referring to the TOS field. So if you look at this part, repeated for each TOS. So it's not different networks, it's different TOS values. But if, as you remember, Cisco supports only TOS of 0. So this is why we would not see these fields repeated in the type 7 LSA. But yeah, here, this is the RFC to look at if you want more information about the type 7 LSA. And I can actually show you from the packet capture as well that although there were several different external networks being advertised in this capture, they're all listed in their own type 7 LSAs. So this was 172.16.3.0, and you can see that there are no repeated fields in this LSA. And similarly, this one, this is the network that is being advertised. There are no others. So we have 4 type 7 LSAs, each advertising a different network. There we go. All right, but that's it for this video. I hope you found this informative, and I will have to come back to the forwarding address and the B-bit and the type 7 to type 5 LSA translation at another video once we've discussed some other concepts. But yes, send me your questions in the comments if something is still unclear. But for now, thank you again for watching, and I'll see you in the next video.